In this chapter, we're going to introduce some of the basic ideas of probability. In this lesson, we're going to introduce you to the idea of a percentile rank.
Okay, in this lesson we're going to take a look at something called percentile ranking, okay, which is another way of analyzing sets of data here. Now, percentiles are numbers from 1 to 99, okay? Now, they can go even a little bit like fractionally higher than 99, I suppose, here, but important to understand here that this does not include 100. It doesn't get up to 100. That is kind of the unreachable ceiling here. But 1 to 99 typically, and are used to compare a data value, add data value to the rest of the set. Okay? Because, I mean, typically you want to know, hey, where do I sit in the group? Okay? Where am I located? How am I doing compared to everybody else here? And that's really is sort of how you have to compare to see how you're doing. Like, you know, when you're in a course or whatever, you're all influenced by the same set of circumstances, whether that be the classroom or the teacher or whatever. So if you do poorly in a class, well, there might be extenuating circumstances that affect that. So to really know how you're doing, you kind of have to compare yourself to the rest of the group. And I know that sounds kind of terrible there, but that's kind of how things work. So the percentile rank of a data value gives the percentage of values in the set lower than the value of interest. So if someone is in the 75th percentile, that means 75% of the population has a value strictly lower than their value. Now, you know, bear in mind here, I don't have to tell you what the values are. That's not the point. That's not the point. 75% of the values are lower than whatever that person's value is. Now, this is sometimes where people get confused when they start working with percentiles, is they confuse the percentile with the data values. But it's the percentile deals with the number of data values that are lower than a given value here, okay? So the percentile rank of a value cannot be 100. Now that's because if you are in the data set, okay, let's think about like this in your class here. Let's say we're going to rank you in the class with a percentile ranking, and you're standing there and you're wondering, maybe you're at the top of the class, the very top of the class here. But you cannot be, it cannot be the case that 100% of the class would be lower than you because you are in the class. You cannot be lower than you. You are the exception to that rule. So it can never be up to 100. Okay? Now, anyway, let's take a quick look at some examples here. Let's see if we can make this make sense to you. Okay, here we go. Let's take a look at this question right here. It says, consider the following data set. So we got your values right here. Which number sits in the position of the 75th percentile? Okay, well, before we do this, what we have to do is we have to put the data in order. Okay? Have to put it in order. So let's go back and use our stem and leaf plot here. So when I look at my stems here, I've got 3, 4, 3, 2. So 3, 4, 2, and a 5. So 2, 3, 4, 5. So I've got 38, 43, 35, 23, 20, 39, 42, 21, 49, 50, 36, and 47. Okay, so now with our stem and leaf plot, what I want to do is I want to organize that data. So again, 2, 3, 4, 5, but now this will be 0, 1, 3. This will be 5, 6, 8, 9, 2, 3, 7, 9, and then 0. Now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got 12 data items here. That's really all I need. Okay, I need to know the total here because I'm going to come up with a percentage based on the number of items here. I'm not going to use these values here. Okay, I'm not going to use like the 23 or the 42 or whatever, except to have them ordered. Once they're ordered, then what I care about is how many there are. So what number sits in this position of the 75th percentile? Okay, well, there's 12 items here. So what I want to do is I want to figure out, well, what is 75% of 12? So I go to my calculator and 12 times 70.75, 0.75, and I get 9. So the number that's in the 75th percentile is going to be larger than 9 of these items. So I count out 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 43, when they're written in order, 43 is the 9th term. The next one, 47, is larger than 9 of them. Okay, that's the first number that's larger than 9 or 75%. So 47 is the number in the 75th percentile. 47 is larger than 75% of the data. Now that I've got the stem and leaf plot, if this makes a couple of these other things a little bit easier to do. What is the percentile rank of the number 36? Well, let's take a look at 36 here. So 36 is right here in my group. So what I need to do is I need to count the number of data values less than 36. So that's 1, 2, 3, 4. So 4 out of 12 values here are going to be less than 36. Now that's 0.33 repeating. Or what we've got here, this is the 33rd percentile. Okay, now this is probably not the best way to write that, but anyway, 33% or the 33rd percentile. Okay, actually, probably better to write it as the 33rd percentile. Okay? Now, what is the percentile rank of the largest number in the set? Okay, well, the largest number in the set is 50. And 50 is larger than 11 out of the 12. It can't be larger than 12 out of 12 because then 50 wouldn't be part of the set. So 11 out of 12. So 11 divided by 12, that is going to be 0.916 repeating. So let's just say 92, 0.92. So it is in the 92nd percentile. Okay? Now, the more data values you have in the group, the higher the percentile can possibly go. The smaller the number, the lower the maximum percentile could be. I mean, because it relates back to the number of items in the group. So hopefully that makes sense. But let's take a look at a couple more examples here. Okay, here's another question. Suppose that 3,000 people wrote a college entrance exam. If 2,450 people scored less than Simon, what is his percentile rank? Okay, well, again, this is very easy. This question here is set up beautifully for a percentile rank. That's exactly what it is. So we just need to figure out what percentage of the population scored less than he did. So we already know that 2,450 did. So 2,450 divided by 3,000, that's going to be about 0.82. Okay, or 80, it's the 82nd percentile. Okay, meaning that he scored better than 82% of the group. Now, if Elliot scored in the 90th percentile, how many people scored better than he did? Now, we had to make a bit of an assumption here, and this would be a little bit easier to talk about in class, but we'll just walk through this here. So if he scored in the 90th percentile, so that means he did better than 90% of the group here. So 0.90, 90% of 3,000. So let's figure that out. 0.9 times 3, 1, 2, 3. So he did better than 2,700 people. But the question is, how many people scored better than he did? Now, we know that there's 3,000 people there. And so if I take 3,000 and subtract 2,700, so 3,000 minus 2,700, I get 300 here. However, that's not true, though. And the reason is because, well, what about Elliot? Okay, he's in this group of 300 people that scored higher than those 2,700 people. So the question is, are there people in there that did exactly the same as Elliot? Okay, if there are people here that scored the same as Elliot, so if some people scored, let's just say equal to Elliot, whoops. Okay, then we don't know. Right? We don't know. I can't tell you, because if they don't tell me how many people scored the same as Elliot, well, then I have no idea how many people did better than he did. But if everyone scored differently, if everybody has a unique score on here, then I know that 299 scored better than he did. Now, 299, because Elliot, there are 300 people that scored better than the 2,700 that we were just calculating here, right? 300 people did better, but Elliot is one of those, which means there are 299 others that must have necessarily done better than he did. If 844 people scored higher than Sarah, and 16 scored the same, so now here's what we're trying to get at here, and 16 scored the same, what is her percentile rank? Well, we need to figure out how many people scored less than her. So we're going to take the full 3,000 here, and we're going to subtract the 844 that did better than her. We're going to score the 16 people that scored the same as her. And then we're actually going to subtract Sarah from that group. So 3,000 minus 844 minus 16 minus 1 is 2,139. This is the number of people that scored less than Sarah. So now we take 2,139 over 3,000, and we get 70, basically, well, it's 0.713, or let's just round that, it's the 71st percentile. Okay, Sarah's in the 71st percentile. She scored better than 71% of the population. Now, by the way, those 16 other people that scored the same mark as her, they also are in the 71st percentile. Okay, this question here says, suppose that the following table shows the number of shoes and their sizes that were sold on a week here. So here's the size. So this right here is your data, but this is the number, this is the frequency that are sold here. So Pamela bought size 8 shoes for her son. What percentile rank are her son's feet? Okay, so her son is right here, size 8. Now, the sizes, though, basically just tell us where to look at the population. What I got to do, first of all, is I got to figure out what the total is. Okay, I'm more interested in the number of items than I am specifically in the size. The size is, again, going to help me kind of split things up here, but I'm really more interested in this number that are sold here. So to start off with, I'm going to create a percent calculation. I need a total. So 10 plus 15 plus 16 plus 27 plus 20 plus 38 plus 24 plus 20 plus 15 plus 9 is 194. So when I do a percent calculation, that's my denominator. Now, her son did better than, that's hard, it's weird to say it like that, did better than. Her son's feet are size 8. They are larger than all of these sizes right here. Well, how many people is that? Well, that's 10 plus 15 plus 16 plus 27 plus 20 plus 38. So altogether, that's 126. So 126 over 194, let's convert that into a percent. And we get that's approximately 0.65, or it's the 65th percentile. Okay, her son's feet are larger than 65% of the group. Now, by the way, there were 24 people that had size 8 shoes. All of them would be considered in that 65th percentile because they're all kind of together at exactly the same position in this kind of ranking here. Now, suppose that someone's feet are in the 21st percentile. What size are their feet? Okay, this is a great question for something like this. Well, the 21st percentile, so I'm going to convert that 21st percentile into a decimal. And I know that there are 194 shoes here. Again, I'm not paying attention right now to the size. It has nothing to do with the sizes. It has everything to do with the number of items that I'm looking at here when they're put in a row. The only reason that I'm looking at the sizes here is because they help me order my numbers. Okay? So I'm following the increasing size of shoes as I'm laying out the numbers here. That's why those are important. Now, 0.21 times 194, okay, is 40.74, 41. Okay, 41 shoes here. So someone's feet here, whoever this person is, their feet should be larger than 41 people here. Well, let's start here. 10. What happens if I add 15 to it? 10 and that's 25. What happens if I add 16? Well, there it is, 16. When I add those up, that's where I get 41. So that means that this person must be in the next group. Because remember, to be in the 21st percentile, you have to be larger than. So I can't be in this group, I got to be larger than it. So that means this person's right there. So therefore, their feet are size 6.5.